Welcome back to the Deep Dive, where we tear open the blueprints of modern IT and really extract the knowledge you need to stay ahead.
hmm
Today, we're moving past all the high-level strategy meetings and the governance documents. We're jumping straight into let's call it the engineering required to make cloud services actually functional.
That's exactly right. And for those of you following along with the strategic roadmap, we're dedicating this whole session to one single crucial subject,
Okay.
the service creation component of the service design process. This is all coming from Module 6, Lesson 3. And this is really where all those abstract ideas about agility and efficiency, this is where they crystallize into actual deployable infrastructure.
So the mission today is pretty precise then. We're looking at the foundational artifacts, and I think that's a key word here. These aren't just technical specs. They are the contractual, the legal, the operational documents that actually automate the delivery. We want to understand how a concept, like, say, providing database as a service, transforms into a robust offering that a user can reliably consume and with zero human intervention.
We're going to trace that entire journey. We really have to unpack the complete DNA of what we call the service offering and examine how policy defines the technical capability.
Okay.
Then we'll scrutinize the service level agreement, I like to call it the contract of trust, and investigate the 5 crucial steps that integrate billing and identity.
And finally,
we have to understand the engine of delivery itself, orchestration. It's sort of the invisible hand that ties all these artifacts together to deliver that speed and consistency everyone wants.
all right, let's get started.
Let's do it.
Okay, so let's unpack this. In the world of IT as a service ITS, what exactly constitutes a service offering? It sounds like a highly technical term, but it feels like it carries a lot of business weight.
It carries all the business weight. I mean, that's not an exaggeration. The service offering is the complete package deal that you present to the consumer.
The whole thing.
The whole thing. It is so much more than just the technical template. You know, the specifications for the CPU, the memory, or the storage. It's that template, but it's combined with all the necessary business context.
Like what?
Like the service level agreements,
Yeah.
all the constraints, the price structure, and of course the required billing information. It's the final product.
So if the template describes the raw ingredients, the flour and eggs, the service offering is the fully baked cake, including the price tag and the guarantee that it won't give you salmonella.
That is a surprisingly good analogy. Yeah.
Tux.
It's the fixed product definition. It defines the core attributes of whatever service instance gets created, and it establishes a really clear line between what is fixed by the provider to ensure standardization, predictability, and what is customizable by the consumer to allow for that necessary agility.
I see. So it's a balance. Can you give me an example?
Sure. Think about an infrastructure as a service server offering. The provider might fix the CPU and memory options to guarantee performance across the entire shared environment.
Right, to prevent those noisy neighbor issues we always hear about.
Exactly. But they might allow the user to select the variable capacity of storage, or maybe choose between operating systems like Linux or Windows or Ubuntu.
That customization is absolutely critical for user adoption, but like you said, the standardization is critical for IT's own efficiency. Standardization, governance, cost reduction. It seems like they're all tangled up together here.
They are.
So where does IT establish the guardrails to manage this balance?
That happens through the constraints, the rules, and the policies that are baked directly into that service offering artifact.
So it's part of the artifact itself.
It has to be. These rules are the mechanisms that translate those high-level governance decisions into automated actions. They ensure that even when a consumer is using self-service, they're always operating within the approved technical, security, and financial boundaries.
Makes sense.
We can really segment these guardrails into 4 crucial categories, and they're all derived from those initial service design requirements.
Okay, let's start with the one that keeps IT managers up at night, security.
Absolutely. We have to begin with security constraints. And these are, frankly, non-negotiable.
Right.
They define the authentication and authorization rules that dictate who can even access or provision or modify the service instance. This is so vital because if the orchestration engine doesn't bake these rules directly into the deployment,
Then what?
then you have a manual security audit just waiting to happen for every single request. It's a nightmare.
Can you give us a concrete failure example? Like, what happens if this constraint isn't automated? What does that look like in the real world?
Okay, so if the authorization is left manual when a new instance is provisioned, a human security officer has to physically or, digitally check the requester's credentials against some access control list.
Like a spreadsheet somewhere.
Probably a spreadsheet, yeah. And then they have to manually configure the associated roles and permissions on that new resource. Not only does that completely kill the instant delivery capability of cloud, but it introduces massive, massive potential for human error.
I can only imagine.
The automated security constraint, on the other hand, ensures that, for instance, a database as a service instance is accessible only to defined individuals within, say, the accounting business unit, and that the data stored on it must be encrypted at rest before the instance is even presented to the user.
So the security check isn't a post-provisioning step. It's not an afterthought. It's an integrated, mandatory component of the provisioning workflow itself.
It has to be. It's step one.
Okay. Moving on to connectivity, we have to define network policies. What does that cover?
So network policies specify exactly how the service instance connects and operates. It's primarily focused on three things: access, security, and quality of service. This covers whether the instance is provisioned with private or public IP addresses, what firewall rules are applied by default, the specific bandwidth quotas that are available to it, and the quality of service, or QoS, guarantees.
QoS is always tricky in a shared environment. I mean, how does the policy ensure one heavy user doesn't just cripple network performance for everybody else on the platform?
That's where the orchestration component, which is guided by this policy, enforces resource isolation right at the network layer. The offering might specify, say, a guaranteed minimum bandwidth, that's the QoS guarantee, and a strict cap, which is the quota.
And how is that actually enforced?
It's enforced through software-defined networking rules that get applied to the virtual switches or the hypervisors. So if a tenant tries to consume more than their allocated bandwidth, the system automatically prioritizes traffic based on that policy. It throttles the excess consumer while protecting the guaranteed throughput for everyone else.
So if you ignore this,
your entire multi-tenant infrastructure can be brought down by a single large data transfer event from one user. It's a huge vulnerability.
and that immediately ties performance to cost, which reinforces the need for that tight policy control we talked about.
Exactly.
Okay, now let's talk about elasticity. This is a core cloud tenet, but it seems to contradict the idea of fixed service constraints we just discussed. What are the elasticity rules?
That contradiction is precisely what the rule set is designed to manage. It's a great point. Elasticity rules are the policies that govern when and how a service instance can scale, whether that's provisioning additional instances, adding storage, or scaling CPU, and critically, under what restrictive conditions.
So this is essential for compliance and preventing resource contention.
Absolutely.
But wait, hang on. If the service template fixed the CPU and memory to ensure standardization, why are we now defining rules that allow the user to potentially ask for more resources? Isn't that undermining the standard?
That's a fantastic and a really critical question. The template defines the standard unit. Think of it as a small, medium, or large server size.
Right. T-shirt sizes.
Exactly, t-shirt sizes. The elasticity rule defines the rules for how many of those standard units you can request, or maybe how quickly you can transition between those standard sizes. It's not allowing infinite custom configurations. It's managing the rate and quantity of provisioning based on real-time availability and governance.
I see. So the rule might say something like, you can scale from small to medium automatically, but only if the overall resource pool is below, say, 75% utilization, and you cannot exceed 10 total instances in this particular geography.
Exactly, and you hit on a key point there. Those geographic regulatory requirements are crucial. An elasticity rule must prevent the provisioning of resources in a region that violates data sovereignty laws, like GDPR, for instance, even if the underlying technology could technically do it.
Right. Just because you can doesn't mean you should.
Precisely. And furthermore, these rules prevent one tenant from consuming too much capacity, which ensures fairness. Without these controls, one resource-intensive application could unintentionally initiate a sort of capacity denial of service attack against another tenant simply by triggering endless scaling requests.
That's a perfect illustration of governance enforced by code. It's not a person saying no, it's the system.
That's the goal.
Okay, finally, storage policies. Data retention and destruction. These are always loaded subjects.
They are arguably the highest risk area in this whole discussion. Storage policies define not just capacity limits, but critical legal requirements. The lease periods, data retention rules, and crucially, data destruction protocols.
So what does that look like in practice?
These policies have to specify what kind of backup schedule is fixed. Is it daily? Is it weekly? And exactly how long that backup data is retained.
So if a consumer deletes an instance, what does the automated policy mandate regarding the data that was on it?
Well, the policy has to dictate the fate of that data once the instance is formally terminated. Does it go through a cryptographic shredding process immediately? Is it archived for 6 months to comply with financial auditing rules before being permanently deleted?
Lots of options there.
Many options, all driven by policy. A fixed policy might state that primary storage must be highly available and encrypted, and that backup data will be automatically deleted after, say, 120 days of non-use. Failing to enforce timely data destruction, that can lead to massive compliance fines and legal exposure just from holding on to data longer than necessary.
That's the real shift, isn't it? IT is moving from simply cabling up a disk drive to defining these structured, policy-laden artifacts that enforce legal and financial requirements automatically upon deployment.
It's the automation of risk management. That's what this is. By codifying these fixed and customizable policies, we achieve standardization, predictability, we drastically reduce chaos, minimize manual administrative work, and we still grant the user the agility they demand.
And this is how IT proves it can deliver modern services securely and compliantly.
Exactly.
All right, here's where it gets really interesting for me. Once the service offering blueprint is set, we move to the commitment, the service level agreement, or SLA. Let's clarify the terminology first, because I think a lot of people get this wrong. What is the fundamental non-negotiable difference between an SLA and a service level objective, an SLO?
You have to use these precisely. It's so important. The SLA, the service level agreement, is the entire commercial and technical agreement. It's the contract. It logically describes the service, its capabilities, the provider's responsibilities, the guarantees, the remedies for failure, and of course the pricing structure. It is focused on the overall service commitment that the customer receives.
Okay, so the SLA is the whole document, the whole promise, and the SLOs are the data points used to prove that promise.
Correct. The SLO, the service level objective, consists of the specific measurable characteristics of that SLA. They are the technical metrics, the targets, like availability percentage, a specific response time in milliseconds, or throughput volume per second. SLOs are continuously monitored. They are the individual components that are measured, and their cumulative performance is what determines if the provider has actually achieved the overall SLA.
So an SLA might promise high availability.
Right. And the SLO would be 99.99% uptime with a latency of less than 100 milliseconds. One is the promise, the other is the measurement of that promise.
Let's discuss the elephant in the room. Cloud environments are shared, they're dynamic. Why are cloud SLAs notoriously difficult to develop, measure, and critically enforce compared to, the old world of dedicated, siloed IT?
Yeah, that's the million-dollar question. We face 3 major hurdles, and they all stem from the dynamic nature of the cloud model itself.
Okay, what's number 1?
First, the complexity of the shared environment. Cloud depends on resource pooling and multi-tenancy. This fundamentally complicates metrics because performance can just fluctuate wildly.
The classic noisy neighbor problem.
Exactly.
So if I provision a database that works perfectly 95% of the time, but for that other 5% I'm experiencing crippling latency because the customer next door suddenly started a massive batch process, how does the provider measure my experience accurately?
That's the core difficulty. The provider often measures aggregate resource utilization, the overall health of the CPU pool, for example. But the consumer doesn't care about the pool. They care about their specific instance latency.
Right. I don't care how healthy the herd is. I care how my cow is doing.
Perfect analogy. In a pooled, multi-tenant environment, the provider's internal metrics often don't accurately reflect the perceived experience of a given consumer. And that makes compliance measurement really contentious.
Okay, so that's the first challenge. The second one, external dependencies. A service can be 100% operational within the cloud provider's data center, but if I'm accessing it from my office across the public internet, all bets are off.
Precisely. If services are accessed via the public internet, you introduce dozens of internet service providers, or ISPs, complex routing protocols like BGP, and regional bandwidth limitations. The cloud provider has zero visibility or control over that last mile of the stack.
So they can't be held responsible for it.
Well, an SLA can guarantee performance within their 4 walls, but if the local fiber connection to your office fails, the user suffers, and the cloud provider is technically not in breach. This requires meticulous delineation in the contract about where the provider's responsibility actually ends.
That massive blind spot shifts a lot of risk back to the consumer.
It does.
Which brings us to the third and maybe the most frustrating point, the proof burden. If I believe my 99.99% uptime guarantee was violated, proving it is, well, it's nearly impossible.
That's the strategic flaw in so many generic cloud contracts. Because providers don't give consumers sufficient visibility into their infrastructure stack, and how could they? It would expose their proprietary architecture. The burden of proof is often placed on the consumer.
So I have to prove they failed.
You have to somehow collect evidence that the provider failed, which is practically impossible without access to the provider's own monitoring data.
So let's be challenging here. If we are designing a top-tier ITR model, our own internal cloud, how do we contractually shift that burden back to where it belongs on us, the provider?
A best practice ITAR's model proactively defines monitoring and reporting as part of the service itself. That's the key.
Okay.
This means the SLA mandates that the provider, in this case, must actively measure and report performance data back to the consumer in real time, or at the very least provide dashboards that offer sufficient metrics.
Yeah, you provide the proof.
You provide the proof. Furthermore, a really good SLA should contractually define third-party monitoring tools that can establish an independent baseline of service availability and latency, binding the provider to those external metrics. If the provider is responsible for measuring and transparently reporting the service levels, they can't hide behind a lack of consumer visibility.
That's a key insight. An SLA without transparency is just a marketing brochure. So let's drill down into the necessary components. Beyond just uptime, what are the 5 mandatory specifications that must be clearly outlined to make an SLA a legitimate binding agreement?
Every comprehensive SLA has to address these 5 areas, no exceptions.
Okay.
First, performance metrics and provider responsibility. This is the core technical promise. It must define the measurable standards availability, throughput, latency, and precisely specify the provider's role in meeting them. For example, if a patching process that we run causes an outage, the provider has to own that responsibility.
Makes sense. Number 2.
Second, business continuity and outages. This must define the critical resilience requirements. We're talking about the recovery point objective, RPO, and the recovery time objective, RTO.
Can you define those for us?
Sure. If the service fails, RPO answers the question. How recent will the recovered data be? RTO answers. How long until the service is fully functional again? These guarantees are fundamental, especially in regulated industries.
Okay, third, let's talk money, because transparency is vital for ITV's success.
Third is pricing. The SLA must specify the service price, including all additional fees, and provide the exact derivation of usage.
What do you mean by derivation of usage?
It means clearly stating if data ingress or egress transfers incur charges, if there's a cost for an idle but running instance, or if there are tiered support fees. Without this transparency, the user gets what we call bill shock, which immediately erodes all trust.
Right. Okay. Number 4.
Fourth, data protection. This covers the whole governance framework. It specifies requirements for privacy, security standards, and compliance. For consumers in highly regulated fields like finance or healthcare, the SLA has to confirm adherence to their internal GRC requirements.
We should probably define GRC here as it's so critical.
Good idea. GRC stands for governance, risk, and compliance. Governance defines the rules and policies, risk identifies and mitigates threats to the business, and compliance ensures you're adhering to legal and regulatory mandates, like GDPR or IDPA.
So the SLA has to basically promise that the service meets the customer's GRC posture.
It must. It's a deal breaker if it doesn't.
And the final piece. What happens when it all goes wrong?
Fifth is service termination and remedies. This outlines the procedures for ending the service, whether that's naturally at the end of a contract or because of a violation. And crucially, the remedies for failure must be defined.
The penalties.
The penalties.
Yeah.
If you promise 99.99% uptime and you only deliver 99.0%, what's the compensation? Is it a monetary refund, a credit toward future services, service credits for the downtime? If the remedy isn't defined, you haven't written an SLA, you've written a wish list.
That's a perfect encapsulation. Now let's talk about management. An SLA isn't static, right? It's a continuous improvement loop that's managed by automation.
It is a dynamic, continuous process driven by feedback. It starts with design. SLA policies are determined based on the actual tested capabilities of the underlying infrastructure. This is a big one. IT must stop selling services their hardware can't actually deliver.
Right, no overpromising.
Then second, those policies are applied to the service template to create the final contractually binding offering. Third, during fulfillment, the service has to be monitored constantly. The orchestration layer interfaces with a real-time monitoring system to track those live SLOs.
And what happens when the performance starts to degrade but before a catastrophic failure occurs?
That's the real beauty of orchestration in SLA management. The system uses orchestration to notify staff or automatically act on performance issues. For example, if the latency SLO begins trending upwards, or if utilization of a critical resource pool hits a predefined warning threshold, say 85%, the orchestration engine initiates a workflow.
Wait, if the orchestration engine automatically adds additional resources to that pool to fix the problem, doesn't that inherently inflate the cost structure and potentially bypass the very cost accountability we were just talking about in the billing section?
That's a sharp challenge, and it really hits the tension point between stability and efficiency.
Right.
The answer is that the automated action is governed by pre-approved elasticity rules that prioritize achieving the SLA over any marginal immediate cost. The cost inflation is justified because the alternative, an SLA breach, is often far more expensive due to remedies, penalties, and of course reputation damage.
So the cost is a means to an end.
It is, and the system tracks the cost of that automatic scale-out and feeds it directly into the billing mechanism, which we'll discuss next. So accountability is maintained. It doesn't bypass the cost, it records the reason for the cost increase, which was preventing an SLA breach. And that's a strategic cost, not an accidental one.
So the orchestration ensures the infrastructure lives up to the promise, even if it has to spend a little extra to do it.
Precisely. And it ensures that all service degradation or downtime is tracked and reported for potential SLA violation purposes, which provides essential input for refining the service design in the future.
Okay, that makes sense.
So we've established the performance promise with the SLA. Now we need to transition to the formal service contract and the critical mechanism of billing. This is the official business and technical subscription.
Right. And in a self-service cloud, there's no paper signing. So how is that binding contract actually established?
The contract is established digitally the moment the consumer engages with the service catalog. Typically, when a consumer logs into the portal, verifies their credentials, and selects an offering, they're presented with a service contract in the form of the terms and conditions, the T&Cs.
The thing nobody reads, but everyone clicks agree on.
That's the one. An agreement to these T&Cs, which have to incorporate the costs, the SLAs, and the SLOs, is what formalizes the subscription. But the very first step, before any of that, is identity verification.
Identity verification is non-negotiable for security, auditing, compliance, everything. How is this handled efficiently?
Verification is based on the consumer's access credentials, their user ID, email, maybe a token, or a client certificate. However, manually verifying credentials for every new service access is, well, it's cumbersome and very error-prone.
So what's the solution?
Which is why single sign-on, or SSO, is the industry standard for authenticity and efficiency in any modern ITIAS model.
SSO allows me to log in once and access multiple services seamlessly. But which specific standards enable this seamlessness across diverse infrastructure components? I mean, we hear terms like SAML, OpenID, and OAuth2 thrown around all the time. What are their specific roles here?
This is a point that often confuses people, so it's good to clarify. They're all what we call federated identity standards.
Meaning
They create a trust relationship between different entities so one entity can vouch for the user's identity to another.
Okay, so let's start with SAML.
SAML, which is Security Assertion Markup Language, is really the traditional cornerstone of enterprise web SSO. It allows a user authenticated by an identity provider, like Active Directory, to access service providers, like a corporate application, without re-entering their credentials. It's often used for internal business apps or federating identity across corporate domains.
And what about the others? They seem more modern.
They are. OpenID Connect, or OIDC, is essentially the modern, simpler layer built on top of OAuth2. It's often preferred for consumer-facing services and mobile applications. It handles the authentication part, verifying who you are.
So OIDC is about who. What about OAuth2?
OAuth2 focuses purely on authorization. It doesn't tell the service who the user is, but rather what they are allowed to access.
Ah, that's a key difference.
It's critical. It grants temporary access tokens to applications so they can use protected resources on a user's behalf. This is crucial in service orchestration, where, for example, the provisioning engine needs an access token to communicate securely with a hypervisor API.
So that distinction, SAML for Web SSO, OIDC for authentication, and OAuth2 for API authorization is vital. It shows how the legal artifact, the contract, relies so heavily on specific automated technical standards to ensure identity integrity.
Absolutely. The reliance on these standards simplifies user management. It maintains credential consistency across potentially hybrid or multi-tenant environments. And critically, it improves customer satisfaction by just removing all that login friction.
Okay, let's pivot to the financial side. The contract is signed, the service is provisioned, and the usage is variable. This requires dynamic, granular billing. How do we integrate billing into this high-speed automated process?
This requires a really tightly orchestrated five-step billing process to track usage granularly. And this ensures accountability and cost transparency. This whole process is foundational for IT to shift from being a legacy cost center to a true profit loss center that can compete with external public cloud providers.
All right, let's detail those 5 steps of billing integration. I want to focus on the architectural necessity of each one.
Okay. Step 1. Metrics definition. This is a design time decision. The appropriate usage information, what we are actually charging for, must be defined and designed directly into the service before it is ever launched.
Before a single line of code for the service is written, almost?
Almost. If the pricing is consumption-based, the application must be designed from the ground up to measure CPU time, gigabytes of storage, network egress volume, API calls, whatever it is, for each user throughout the entire service stack. If you don't define it here, you can't charge for it later. It's that simple.
Which means the engineering team has to work closely with finance and legal to determine what even constitutes billable consumption.
Precisely. Which brings us to step 2, metering integration. When the service is instantiated, the orchestration layer interfaces with the usage metering system to track real-time consumption. This system is automatically activated upon service deployment, and it tracks consumption metrics constantly.
And this is just for billing.
Not just for billing. This metering is also leveraged to control resources. For instance, if a user hits a predefined usage limit, the metering system can trigger an alert or even a soft shutdown based on the policy.
Okay, what's step 3?
Step 3, billing system interface. The metering system feeds these raw, real-time usage metrics directly to the centralized billing system. This system's job is to aggregate all the raw consumption data from all the different meters across all the services for any given consumer.
And step 4?
Step 4, reporting mechanism. The aggregated usage and cost information are then provided to the centralized reporting mechanism. This component allows IT management to receive service metric reports showing consumption trends, cost allocation, and crucially, SLA fulfillment status tying performance right back to value. This is the mechanism that proves IT's financial value to the business.
And finally, we get a bill.
Step 5, invoice production. Finally, the billing system generates and produces a detailed, itemized invoice for the service consumer. This automated process ensures complete cost transparency, allowing consumers to see exactly what they paid for and why. And that encourages them to right-size their demand and promotes overall resource efficiency.
The automated connection between resource consumption and the final invoice, that really is the definitive separation between legacy IT and a modern ITAS provider, isn't it? It moves you from estimated budgeting to granular cost accountability.
And that transparency prevents waste. I mean, if consumers know that the server they left running over the weekend, even if it was idle, is costing them money, they are much more incentivized to terminate it, which frees up that capacity for others.
Okay, so we have finalized the blueprint, which is the template. We've defined the contract, the SLA, and the price, and we set up the cash register with billing integration. Now for the crucial part. How does the service actually transition from a blueprint to a functional reality? This is the domain of orchestration.
Orchestration is truly the heart of the cloud model. It is the automated arrangement, coordination, management, and monitoring processes that enable self-service, elasticity, and rapid provisioning through sophisticated workflow automation.
We often confuse orchestration and automation. I feel like these words get thrown around a lot. Can we use a strong, memorable metaphor to distinguish between the two? Because that difference seems strategic.
It is strategic. Let's think of it this way. Automation is the bricklayer.
Okay.
It is the codification of a specific, individual, repetitive task, say, running a script to configure a firewall port or installing an operating system patch. It provides the muscle for one task.
One specific job.
One job. Orchestration is the architect and the project manager. It's the codification of a larger, complex process or workflow. It takes dozens of those individual automated tasks, it sequences them logically, it manages their dependencies, ensures they communicate via APIs, and it spans multiple devices, applications, and solutions across the entire data center stack.
So if I want to provision a server, automation is the script that installs the operating system.
Right.
But orchestration is the whole end-to-end process. Checking my credentials, calculating the cost, ensuring compliance policies are met, then running the automation script to install the OS, then configuring the network, connecting the storage, activating the meter, and sending me a confirmation email, all in the right order.
Exactly. Orchestration provides the workflow intelligence. Automation provides the low-level muscle. Without robust orchestration, you can have 1,000 perfect automation scripts, but the end-to-end service delivery remains manual, slow, and prone to inconsistency and high risk.
And that entire process is initiated by the service catalog. It's not just an interactive list. It's really a point of entry for all this governance we've been talking about.
The service catalog is the primary vehicle for consumers, but functionally, it's the initiator of the action and the enforcer of choice. When a consumer requests a service and selects their customizations, maybe choosing a specific application stack or a storage tier or a region, the catalog translates that human request into machine instructions. It triggers the orchestration engine based on the selected service offering.
And how does the catalog enforce the policy?
Well, it acts as a gatekeeper, because the catalog only presents approved service offerings, those artifacts that already have the governance policies for security, network, storage, elasticity baked right in. The user can only select compliant options.
So you can't even ask for something that's out of bounds.
You can't even see it.
Yeah.
This ensures the provisioning process automatically adheres to the predefined protection and security policies we established earlier. And furthermore, the catalog dictates which metrics need to be collected, linking the service request immediately back to the billing and metering process.
A service catalog without an orchestration engine is merely a brochure. The engine makes it an action tool.
That's a great way to put it.
So let's walk through the full, tangible workflow. How does the orchestration engine instantiate a brand new service instance from the moment I click Submit?
Okay, this involves a highly intricate, automated chain of command. It involves at least 5 steps and multiple systems, all communicating via API calls.
Let's go through them. Step 1.
1. Consumer request and policy check. The consumer submits the request via the catalog. The catalog immediately checks the user's identity, probably via SSO, and the compliance of the selected configuration against all the policies embedded in that offering.
So I check right at the front door.
A check before anything else happens. 2. Orchestration engine trigger. Assuming everything is compliant, the request moves to the orchestration engine, which kicks off the predefined workflow. This workflow immediately interfaces with the provisioning manager. That's the component responsible for actually assigning the resources.
And where does it get the information about resources?
That's step 3, resource query against CMDB. The provisioning manager queries the configuration management database, the CMDB, to retrieve up-to-the-minute resource information. It needs to know the current availability, location, and specific configuration parameters of all the required components, compute, network, and storage. This check is crucial for capacity management and policy enforcement.
So it's making sure that only resources compliant with the service offerings policy are even selected for the job.
That's right, which leads to step 4, cloud infrastructure provisioning. Based on that CMDB data, the provisioning manager communicates with the cloud infrastructure itself, the virtualization layer, the software-defined network controller, and the storage array manager. It executes all the necessary API calls to instantiate and configure the requested resources exactly according to the template characteristics.
And the final step is delivery.
5. Service delivery, monitoring activation, and status reporting. The compute resources are started, the security policies like firewalls and auth are applied, the network is connected, and the usage meter is activated. The consumer is then presented with the fully configured and running service instance ready to go.
That seems like an enormous amount of work to happen in seconds, not days. And throughout that entire complex multi-system workflow, how does the system maintain reliability? I mean, what happens if one small step, say, configuring the firewall fails?
Reliability rests entirely on the orchestration engine's capability to handle exceptions and report status. It's a huge part of the design. It must monitor every single API call and every external system response. If the firewall configuration fails, the workflow must be designed to either retry the task a few times or, more commonly, trigger an automated rollback process.
What's a rollback?
It cleans up any partially created resources, logs the error for IT staff to review, and then reports the failure status back to the consumer so they know what happened. You can't leave things half-built.
This highlights why manual steps just defeat the entire purpose. If there were one manual approval step in there, or a human needing to verify a configuration change, you would lose the speed, the consistency, and that zero-touch capability that really defines the cloud model.
Precisely. If you are aiming for high-volume automated service delivery, variability and manual error must be removed entirely. By focusing on standardizing the service offering and using orchestration to enforce governance through automation, IT realizes these substantial economies of scale and truly becomes a strategic, agile provider. The entire lifecycle, from request to termination, must be managed by this engine.
So the ultimate takeaway here is that IT as a service isn't achieved by just virtualizing your infrastructure. It's achieved by codifying every single layer of planning, governance, finance, and technical standards into these actionable service creation artifacts.
Exactly. We focus today on how governance policies, financial transparency, and architectural design all converge in the service creation phase. We've successfully moved from abstract strategy to tangible, actionable deployment mechanisms like the service offering template and the comprehensive SLA.
And for you, the listener, understanding these creation artifacts is the absolute key to managing risk, ensuring consumer satisfaction, and, frankly, maintaining competitiveness against external public cloud providers. The detailed architecture we discussed from Module 6, Lesson 3, is what enables IT to shift from being a bottleneck and a cost center to becoming a strategic, value-driven, agile partner that speaks the language of compliance and finance.
And this raises an important question for you to consider. We saw how orchestration actively monitors and manages SLOs, scaling resources and preventing failures. But in a highly dynamic cloud environment, where resources are constantly shifting, scaling, and potentially migrating across heterogeneous hypervisors and even across public and private cloud boundaries, how does an organization ensure continuous, holistic visibility and unified operational control across all these shifting service components? How do you avoid gaps in management or reporting when the service itself is a moving target? That's something to mull over as you think about the next steps in continuously managing and optimizing these newly created services.
A fascinating and critical challenge for the modern IT professional. That's all the time we have for this deep dive. Thank you for joining us as we unpack the service creation component of ITIAs. We'll see you next time.